This right here is an example of a problem involving circles, arcs, tangents, chords, secants, all that vocabulary that has to go along with circles. And depending on what chapter you're on, your textbook, your unit, the way that your teacher or textbook follows the curriculum, I don't know exactly where this problem starts or begins, but it does appear in the unit for circles. So this is what I like to call the two tangents theorem. As you can see, we have one tangent going from A to B or B to A. We have another tangent that's going from A to D or D to A, and we have a circle. So whenever you have two tangents and they meet at the exact same point outside the circle, you are allowed to set these segments equal to each other. I should say these segments are congruent, so let's write that out. We are allowed to say that segment BA must be congruent to segment DA. And since you're given a couple of algebraic expressions for those segments, go ahead and substitute them in and solve. So BA is 7x plus 4. We'll set that equal to DA, which is 3x plus 68, and continue solving. Depending on how you prefer or your teacher prefers you to do your algebra, that's fine. I'm just going to isolate the variable, so and I will leave you to get your answer. But this is, again, what I like to call the two tangents theorem. Two tangents theorem. And all it says, if you have two tangent lines meet at the same point outside the circle, you are allowed to set these segments congruent to each other.